Ever found yourself pondering the possibility of living forever, not in flesh and blood, but as a digital entity? Welcome to the concept of digital immortality, the idea of uploading your consciousness into a digital realm, effectively living on long after your physical body has ceased. An idea that isn't just the stuff of sci-fi novels anymore, but a concept explored in the popular game, Cyberpunk 2077. The premise of this fascinating concept, however, hinges on three pivotal assumptions. First, that our mind, our very essence, can be found within our physical brain. Second, we can accurately replicate this complex organ in a digital format. And third, our minds, with all their intricacies, can be computed and hosted by sophisticated computer software. In the next few minutes, we will delve deep into the intriguing world of digital immortality. Buckle up, it's going to be a wild ride. First off, let's tackle the assumption that our mind can be found in our physical brain. What we call the mind is often considered synonymous with consciousness, thoughts, feelings, and memories. This intricate web of experiences and perceptions is believed to reside within the confines of our physical brain. But is it as simple as that? Consider the brain, a 3-pound mass of jelly-like tissue, teeming with around 100 billion neurons. These neurons are interconnected in a network so complex, it puts even the most intricate computer systems to shame. Each neuron, through its thousands of synapses, can connect to tens of thousands of other neurons, creating a sophisticated network of communication pathways. This neural network is the physical basis of our thoughts, emotions, and memories. The mind, as we understand it, is the product of this complex, dynamic system. However, the mind is not a tangible thing that can be held in one's hand or seen under a microscope. It's a process, a product of the brain's operations. It's an emergent property of the brain's complexity. It's not an object, but a phenomenon. Trying to locate the mind within the physical structure of the brain is akin to trying to find the wind in the trees. Just as the wind is the movement of air and not the air itself, the mind is the process of neurons firing, not the neurons themselves. Moreover, the brain is not a static structure. It's constantly changing, adapting, and learning. This property, known as neuroplasticity, means that our minds too are in a state of flux. Our thoughts, emotions, memories, and experiences are continuously shaping and reshaping our brains. It's clear that the brain is an incredibly complex organ, and understanding it fully is a monumental task. Despite significant advances in neuroscience, we're still far from comprehending the brain's intricacies and the nature of the mind. So, while our mind may be an intricate product of our brain, pinpointing its exact location is not as straightforward as it sounds. Moving on, we come to the second assumption, which is that we can accurately replicate the brain in digital form. This, my friends, is no small feat. The human brain is an intricate marvel of nature, holding some 100 billion neurons, each with thousands of connections. Picture a bustling city, teeming with life and activity. Now multiply that by 1,000, 1,000,000, 1,000,000,000. That's the scale we're talking about. Currently, our advancements in brain mapping and digital replication have made some impressive strides. We've created digital twins of simpler brains, like those of fruit flies and flatworms. We've used machine learning algorithms to trace the intricate pathways of neurons. And we've built complex models to simulate the firing of these neurons. But let's not get ahead of ourselves. The difference between a fruit fly's brain and a human's is like comparing a puddle to an ocean. The complexity of the human brain is staggering. Each neuron's firing depends on a delicate balance of chemicals and electrical signals, influenced by a myriad of factors, from genetic coding to environmental stimuli. And it's not just about the neurons. There are also glial cells which outnumber neurons by nearly 10 to 1. These unsung heroes of the brain provide support and protection for neurons. And recent research suggests they play a role in cognition and behavior as well. So we're not just looking at mapping 100 billion neurons, but also a trillion glial cells. And then we have to understand how they all interact, how they change and adapt over time, and how they create the symphony that is human consciousness. The computational power needed to simulate all these elements is currently beyond our grasp. And even if we had it, we'd still face the challenge of accurately collecting and interpreting the data from a living, changing brain. Clearly, the journey to accurately replicate our brain in the digital realm is still a long and challenging one. But we're making progress, small steps towards an understanding that could change our perception of life, death, and what it means to be human. The third assumption posits that our minds can be computed and hosted by computer software. This idea is rooted in the computational theory of mind, which suggests that the mind functions like a computer. In other words, our thoughts, feelings, and consciousness could theoretically be reduced to data processing and information transfer. But let's not get carried away. This is no simple task. The brain isn't just a biological computer with binary code. It's a complex analog system with countless neurons firing in a dizzying array of patterns. To transform this intricate web into digital code is a gargantuan challenge. Consider this: our brains aren't just about data storage, they're about data interpretation. When we experience something, our brain doesn't just record the event, it interprets it, imbues it with meaning. It's this interpretive function that makes our experiences uniquely our own. How then do we translate this into a binary code? And then there's the issue of consciousness. Can a computer program truly replicate the subjective experience of being human? Consciousness isn't just about processing information. It's about experiencing the world in a deeply personal way. It's the smell of your first cup of coffee in the morning, the warmth of a loved one's hand in yours, the heartache of loss. Can these experiences be computed? And let's not forget about the sheer amount of data we're talking about. The human brain is estimated to have a storage capacity of around 2.5 petabytes. That's the equivalent of 3 million hours of television shows. Imagine trying to store, process, and interpret all that data in real time. Even with today's most advanced technology, we're far from achieving that level of processing power. As fascinating as it is, the idea of computing our mind and hosting it on a software platform is still quite a leap from our current capabilities. Now, let's imagine we have overcome these challenges and mind uploading is a reality. What implications could we expect? Well, firstly, let's consider how this might change our outlook on life. If we knew we could live forever in the digital realm, would we still cherish our physical existence in the same way? Or would we start to see it as a mere stepping stone to a more permanent digital life? And how would this affect our relationships, our ambitions, our fears and hopes? Next, consider the manipulation of memories and personalities. In a digital realm, it's plausible that we could edit our minds, alter our memories, even change aspects of our personalities. But is this ethical? And who gets to make these decisions? Would we still be us if we could cherry-pick our memories and traits? Or would we risk losing our identity, becoming a mere collection of selected experiences and characteristics? And then there's the potential division among humans. If mind uploading becomes a reality, it's likely not everyone will be able to afford it, leading to a class division between those who can achieve digital immortality and those who remain as meat beings. This could create a society where the digital elite holds sway over the mortal masses, further deepening the divide between the haves and have-nots. And what of the digital minds themselves? Would they have rights? Could they vote, own property, marry? Would they be considered citizens or something else entirely? And would they be bound by the same laws as us, or would they exist in a legal limbo, neither fully human nor fully machine? These are just some of the complex social and psychological implications of digital immortality, and they raise more questions than answers. But one thing is certain, the implications of mind uploading are far-reaching and profound, affecting not just individuals, but society as a whole. Indeed, the future of digital immortality is as thrilling as it is daunting. In the end, whether mind uploading becomes a reality or remains a fascinating concept, it certainly gives us much to ponder upon. We've delved deep into the assumptions that underpin this idea, the location of our minds within our physical brains, the feasibility of accurately replicating these brains in digital form, and the notion that our minds can be computed and hosted by computer software. We've also explored the intricate complexities of the brain and how the translation of our brain's structure and biochemistry may not necessarily equate to consciousness. From the social and psychological implications of digital immortality to the potential divide between digital minds and meat beings, the concept of mind uploading presents us with a future that is both thrilling and daunting. As we continue to explore the frontiers of our minds and technology, we may yet uncover the secrets of digital immortality. Until then, keep questioning, keep exploring,